So in this video, we continue our discussion of infinite series. We look at the direct comparison test again. This time, we look at the second part. The second part of the direct comparison test states, suppose there exists a finite integer n such that 0 is less than or equal to b sub n is less than or equal to a sub n for all values larger than that finite n. If b sub n diverges, then the series a sub n diverges. So recall when we dissected the first part of this direct comparison test, order mattered. And in this case, notice the a sub n terms must be larger than the b sub n terms. And I liked to look at this in a two-dimensional picture. So if we look this time, a sub n is the larger of the two circles that we're going to be comparing. So a sub n is bigger, and the terms b sub n are smaller. And so when I draw my picture to visualize this idea, b sub n is in the middle, and a sub n is larger, and that one is on the outside. And what is this test telling us? This test is telling us if b sub n diverges, and by diverge, I think explode. It diverges. It grows infinitely big and explodes. And so as b sub n diverges, what's happening? It's getting larger and larger and larger. And so what is it forcing? It's forcing a sub n outwards to do the same thing. So as b sub n is exploding and diverging, a sub n also has to explode and diverge with it. That's the idea behind this part of the direct comparison test. So let's get right to it and do a mathematical example. So this is actually the third example we are doing for the direct comparison test. Example 3, use the direct comparison test to show that the following series diverges. This time we are starting with the infinite series n equals 2 to infinity of 3 over the square root of n minus 1. This is our series a sub n. The direct comparison test requires us to find another series to compare to. So we'll call that series b sub n. What should we decide to let b sub n be? Well, my guess is we want to incorporate this square root of n. And in fact, I might be inclined to compare this particular series, 3 over the square root of n minus 1, to the series 3 over square root of n. Now, I'm just guessing. But let's check and see. Let's write down some order, and let's start with what we know. We know that the square root of n is going to be larger than the square root of n minus 1, where n is any number, finite integer that ranges from 2 to infinity. We also know from a previous discussion that when I invert square root of n, in other words, take 1 over the square root of n, and compare it to 1 over the square root of n minus 1, that if square root of n is larger than the square root of n minus 1, when I take the reciprocals 1 over square root of n and 1 over square root of n minus 1, I actually get that 1 over the square root of n is smaller than 1 over the square root of n minus 1. And if I now go ahead and multiply 3, the positive number 3, on both sides, I get the statement that 3 over the square root of n is smaller than 3 over the square root of n minus 1. I now have a relationship between my a sub n term and my b sub n term. Should I choose 3 over square root of n to be my b sub n series? So I think that's what I'm going to do. I'm going to let b sub n equal 3 over the square root of n. And recall, 3 is a multiple, a constant multiple, so I can pull that outside of my series. So really what I'm looking at is 3 times the series 1 over the square root of n. And what is that? Oh, it's a p-series, isn't it? It's a p-series in disguise. Square root of n is n to the 1/2. This is a p-series, and in this particular p-series, I have that my power is 1/2. 1/2 is smaller than 1, and so that tells me that this particular p-series does what? It diverges. So here we have a p-series, and it diverges. We also have an order where the b sub n terms are smaller than the a sub n terms. Let me draw a picture and make sure it all works out correctly. B sub n is smaller, and therefore if I'm drawing circles to kind of get an idea to make sure and check what's going on here, B sub n is smaller. It's smaller than A sub n. So A sub n's on the outside. And if B sub n diverges, because it is a p-series that diverges, it's going to explode, diverge to infinity, and grow infinitely large. And as it does, it takes A sub n with it, and A sub n is also forced to diverge. So it looks to me like what we have going on is we have that our original series A sub n is a diverging series by the direct comparison test. Let's write this out officially. So we let the series B sub n be the infinite series n equals 2 to infinity of 3 over the square root of n. This series diverges, and it diverges by the p-series test. Moreover, we have an order. We know that 0 is smaller than 3 over the square root of n, which is smaller than 3 over the square root of n minus 1. And those two facts combined tell us, therefore, that our original series n equals 1 to infinity of 3 over the square root of n minus 1 also diverges, just as the b sub n series did. And it diverges by the direct comparison test.